Hi, this is Mrs. Tiglis,
And Miss McCauley's here too.
and today we're going to talk to you guys about symmetry and reflections.
Okay, Mrs. Tiglis is going to be up at her board and she is going to walk you through the note sheets. Make sure you write down everything that she writes down, just like you normally would. All right, Mrs. Tiglis, tell us what symmetry is.
Symmetry is figures that match exactly when they are folded in half. So you may have heard this word before. Let's get this down. Figures that match exactly when folded in half have symmetry.
You will notice that Mrs. Tiglis has drawn a line through the center of the butterfly and shown that that also has symmetry. If you folded that butterfly in half, you would have an exact match.
So this is a regular pentagon, which means that all of the sides of the pentagon are the same. And what we need to do is figure out all the lines of symmetry. Now, this one gets a little bit tricky. A rectangle is much easier. But here's how we would find that. We're going to start at each vertex. Okay? A vertex is where the two lines meet. And then if you draw a line through across to the opposite side and get it about halfway through, that right there would be a line of symmetry. Because if you fold it in half, both sides would be the same. So this would be one line of symmetry. I'll label it right there. The next line, I'm going to start at this vertex. Go straight down. That's the second line of symmetry. The third is going to be the same way.
Mrs. Tiglis, can I interrupt for just a second?
Sure.
Hey, if you guys are doing this in GoodNotes, you should use the line tool that's on your GoodNotes to make a nice straight line when you're drawing the symmetry, because or the lines of symmetry, because it's sometimes hard with GoodNotes.
Perfect. I totally agree. I wish I had good notes right now. Okay, and then this would be the fourth one. Again, I'm going from the vertex to the middle of the opposite line segment, and the final one would be right here. Okay? Technically, these should also all have arrows at the end because we all know that lines go on forever.
Cool. Mrs. Tiglis, is it true then? Because I noticed it's a five-sided figure, a pentagon, and it has five lines of symmetry. Is that what we should always look for?
Yes. As long as it is a regular figure, which means that all of the sides are the same length, then however many sides that figure has, that's how many lines of symmetry it would have.
Cool. Wow, Mrs. Tiglis, what are you doing there with that mirror?
I'm looking at my reflection.
Wow.
So reflection means a mirror image of the original figure. A mirror image of the original figure. So mathematically, what we're going to be doing with this is we're going to have figures and we're going to be flipping them over lines of symmetry. Let me show you how. Okay, let's take a look at the next problem. Here it says triangle XYZ has vertices, and then it lists what all the vertices are. And then it tells us to find the coordinates of XYZ after it's reflected over the x-axis. We then are going to have to graph the figure and its reflected image. So it's a lot easier for you guys to see this on GoodNotes. If it doesn't look clear enough, feel free to draw over it just like I did. And you can use the shape tool. So our original triangle XYZ is right here in blue. So vertex X, or the point X of the triangle, is going to be where the X value is -2 and the Y value is 4. So just like you guys learned about graphing in the coordinate plane, we would start at the origin, go to the left 2, and up 1, 2, 3, 4 to give us point X. Then point Y is at 5, 1. Again, we would go 1, 2, 3, 4, 5, and up 1. Point Z on the original figure is at 6, 2. 1, 2, 3, 4, 5, 6, and up 1, 2. So far, all we've done is graph the original image, which should be review and should be pretty easy for you to do.
Perfect. Then what do you do next?
So now we want to see what happens if we flip this over the x-axis. So remember, the x-axis is our horizontal axis right here. Okay? They've already drawn it for us in our notes, but let's take a look at what's happening. Okay? So our new point x, our original point x, remember, was 1, 2, 3, 4 units away from the x-axis. When we look at our new point x in the reflected figure, it is 1, 2, 3, 4 units away from the x-axis, which is exactly what we're given right here. Okay, so now we have to figure out, well, what is this? If we had to list the coordinates, the x and y values for this point, it would be at -2, 1, 2, 3, 4. At -2, -4. So let's write that here. Now, you may notice that there's this little apostrophe next to the x. We call that x prime. That in math, that little apostrophe, we use the word prime, kind of like Amazon Prime, okay?
My favorite thing.
And so the coordinates of this next point are at -2, -4. Let's take a look of where y prime and z prime are and see if we can see any relationship between the points. Okay, so y prime right here is at, our x value is 1, 2, 3, 4, 5, and our y value is -1. So this would be at 5, -1. And finally, z prime is at 1, 2, 3, 4, 5, 6, -1, 2. So this would be at 6, -2. Now, if we compare x and x prime, what we notice is our x values are the same. They were both -2. But when we look at the y value, it is opposite. So in x it was 4, and x prime it's -4. When we look at y and y prime, it's the same thing. The x value is the same, it's 5 for both of them, but the y value is opposite. It went from 1 to -1. And then when we look at z and z prime, again we notice the same thing. Okay, the x value is 6 in both of them, and the y value is the opposite. It goes from a +2 to a -2.
That's cool. Mrs. Douglas, wouldn't it be fair to say that, like, if it's the opposite, that's the same as the additive inverse, right?
That's exactly right. I'm so glad you remembered that vocabulary.
Wow.
Yes, we can say additive inverse is another name for the opposite of the number. And that's going to be really important.
Okay.
Okay, so the next page in your notes is blank. And it's very important that we get these rules down. So even though I already have it written, you can pause the video here so you can see what it says and make sure that you get these notes down. When you are reflecting an image over the x-axis, over the horizontal axis, your x-coordinate is going to stay the same and your y-coordinate is going to be the opposite. If you're reflecting an image over the y-axis, the vertical axis, then your y-coordinate is going to stay the same and your x-coordinate, you're going to take the opposite of that. So make sure you write this down so that you always have it to look back at, and then we'll do a couple examples in just a minute.
Okay, and also remember that opposite, if it's a positive number, the opposite is negative, and if it's a negative number, the opposite will be positive. The digits should stay the same.
Okay, so now let's take a look at a problem. The directions here say graph the triangle, and then it gives us the 3 points, and its reflection over the x-axis. Write the coordinates of the reflection. So I highlighted the x-axis so we don't make any mistakes there. So it says to graph the triangle and it gives us all the points. The first thing that I want to do is figure out what my new points are going to be. Okay, so if we are reflecting over the x-axis, that means the x values stay the same. So the 4, the 7, and the 10 of our original points are going to stay the same. I'm going to write those for A prime, B prime, and C prime right away. So A prime, the x value is at 4, B prime, 7, and C prime, 10. Now the y value has to be the opposite. So in A, it was 2. The opposite of 2 is -2. B, it was 7. Opposite of 7 is negative 7. And C is 3, so the opposite would be negative 3. So I'm going to go ahead and I'm going to graph the original figure, the original triangle that they gave us in the problem. So point A is at 4, 2. So I'm going to go to the right 4, up 2, and make a point. Remember that you have to make both the point and label the letter. Okay, you need to have both of those things. Point B is at 7, 7. So I'm going to go to the right 7 and up 7. And then point C is at 10, 3. I'm going to go to the right 10 and up 1, 2, 3. Okay, again, use your shape tool in GoodNotes to make nice straight lines. There is our original figure. Now I'm going to graph the reflection. I'll use a different color. So we know A prime now is going to be at 4, negative 2. So I go to the right 4, down 2. I'm going to draw my circle and label it A prime. Okay? Then B prime, 7, negative 7. That is going to be right here. And again, it's labeled B prime. And finally, C prime is at 10, negative 3. I'm going to go to the right 10 and down 3. Use your shape tool. And as you can see, it looks like we just took this triangle and we flipped it or reflected it over the x-axis. Okay, so now let's try one final problem. This one says to graph the quadrilateral, and it gives us all of the points, and its reflection over the y-axis. So in our head, we can kind of think about what this is going to look like. We're going to have a quadrilateral, and it's going to flip over the y-axis, which is highlighted for you. So this time, let's go ahead and graph these points first.
Hey, Mrs. Tiglis, what's a quadrilateral?
Oh, well, a quadrilateral is a four-sided figure. The word quad means 4, so we know it's going to be a 4-sided figure.
Cool.
Okay, so point W is at negative 10, 0. That means we're going to go to the left 10 on the x-axis, and we're not going to go up or down at all. Let's put our point there and label it W. Our next point is at negative 3, 0. Again, it's going to be right here, right on the x-axis. Y is at negative 9, 5. Negative 9 on x, 1, 2, 3, 4, 5. And we're going to label this Y. And finally, point Z is at negative 4, 6. 1, 2, 3, 4, 5, 6. Go ahead and use the shape tool to make it look good. And you should have a figure that looks like that. Now, before we try to just randomly graph what we think it might look like, we must figure out what our new coordinates are going to be. And this time, it's the opposite. So our y values are going to stay the same because we're reflecting over the y-axis. And our x values are the ones that are going to be the opposite. So for point W, the opposite of negative 10 is positive 10. So W prime would be at 10, 0 because our y value stays the same. X prime, we have to take the opposite of our x coordinate, and our y coordinate is going to stay the same, so that would be at a positive 3, 0. Next, y, that would be at positive 9 because we have to take the opposite, and positive 5 because our y value stays the same. And finally, point Z would be at positive 4, positive 6. Couple quick things here that I want you to notice. First of all, 0. If you ever have to take the opposite of 0, which we did not have to in this case, but if you ever see 0 and then you're trying to take the opposite, remember that 0 is not positive or negative. So if you are at point 0, that would just stay a 0. The other thing that I kind of want you to be able to see right now is you guys should be able to tell that we're in quadrant 2. When we flip this over, because all of our new points are positive, we're going to end up in quadrant 1. Okay, and so that should make sense with the fact that both the x and y coordinates are positive. So now why don't you pause the video, try to graph the reflected image, and then come back and see if you did it correctly. Okay, so now that you've already graphed it, does your image look like this? It should. There's a couple things that you need to make sure of. Do you have a point at all of these? Did you label x prime, y prime, w prime, and z prime? And did you connect it? Hopefully yours looks better than mine if you use the shape tool, but it should look just like this. And it looks like we took this figure and flipped it over, okay? So that's all for now. Please go ahead and complete your note check. And if you're confused or stuck on anything, make sure to ask your teacher for help.
Mrs. Tiglis, what's the note check?
The note check is the Google form that's right after the video and the note sheet that you just watched.
Oh yeah, my teacher asks me about that every single time I watch a video.
Make sure you do it.